Hello everyone. I thought that instead of taking class time to do the introductory material for Chapter 6, I thought I'd see if I can use some of this technology that I'm learning in the class that I'm taking. So I'm going to do this video to introduce Chapter 6 properly. Chapter 6 is all about transportation fundamentals, and as I said earlier, we've already covered a lot of these in previous courses that you've had, both BA 331 as well as the Logistics 310 class. In normal Dr. Blue fashion, however, he introduces the chapter, as he always does, with a quote. This one talks about when the Chinese write the word crisis, that they tend to do so using these two characters, one meaning danger and the other opportunity. And it certainly is appropriate for today's environment, where when we look at what's happening in transportation, we see the opportunity side of things being more about strategic relationships, and the danger really being several things that are on the horizon. The change in the hours of service regulation. We talked about the CASA 2010 that's calculating the score for drivers themselves, and the fact that these are really affecting the amount of capacity that's in the marketplace itself. So with that in mind, let's look at where we are on the roadmap for this course. We've left our middle triangle looking at customer service goals, and now we're going to start talking about this whole idea of a transportation strategy itself. The transportation system is really about two, I wouldn't say competing factors, but I would say two factors that look at both the cost and the service side itself. On the performance, these are all key performance indicators, or KPIs, that we've looked at before. Average transit time variability. If you look at the average transit time and the variability together, they really combine a significant part of the order cycle time itself. We've talked about loss and damage and how it's one of those critical service impacts. And you'll see now we're talking about availability and capability. Those two are very different terms. Availability simply means that we have the capacity and we are willing to move the freight. Capability says just that. Are we able to? A great example of that and how to define it might be that I might be willing to take on freight that's hauling, say, large panes of glass that might be going into a commercial building or something. But unless I have the specific equipment to be able to haul that, then I'm not capable. Things that would fall into this category would be things like hazardous materials or even radioactive materials themselves. Another component of the transportation system has to do with cost. We'll talk about the line haul, which is just simply the point-to-point. It's the over-the-road portion. Generally, the mode of transportation that has the most significant and the primary cost is line haul will be truckload. And then we have terminal and local, and this comes into play when we're moving freight between nodes in the network, and this is generally associated with the less than truckload. And then we have these accessorial charges. Now the accessorial charges can really be anything from fuel surcharges to detention and demurrage. It could be about diversion, special handling. It could be the tolls that we pay when we use highways that are set up that way. One I've seen recently is vehicle ordered and vehicle not used, vehicle repositioning fee. I've even seen lumper fees in this category. And last but not least, since we've had so much pressure on keeping the equipment rolling, I've even seen a charge for making a driver wait an excessive amount of time. The importance of the modes are something that you've covered in the previous classes, and I know I'm saying that a lot, but I think it's true. So if you need to go back and take a look at this material, please do. But these are broad generalizations that I think if you keep in mind, the modal selection itself is usually a pretty straightforward one when you're looking about the value of the good and how sensitive it is relative to that cycle time and how quickly it needs to move. The importance of the mode, another way of categorizing that would be looking at the volume that's moved. And you'll see here we have our 5 primary modes of transportation. Now, these statistics are, I wouldn't say misleading, but I suspect that many of you could have already told me if we ranked them by volume moved that it would have ended up like this. It has to do with the capacity of the mode itself and how many commodities they're capable of moving. So railroads beat out trucks simply because if you look at the amount that we can get in every rail car, whether we're moving grain, coal, sand, whatever it happens to be, is so much greater than the trucks that we have over the road. If we looked, however, at the revenue freight that's moved, it would probably be trucks, followed by railroads, probably followed by oil pipelines, then followed by air, and then inland waterways. So please be aware of the fact that that ranking is really going to be about the particular metric we're using, which in this case is volume moved. The performance overview, and just kind of wrapping up this part of the discussion, are things that we're all aware of. If you look at the pipeline, it talks about it being very slow but reliable. Many people refer to the pipeline as a rolling warehouse, and I think that that's a very true characterization. If you look at what's moving by barge, now remember this is not ocean transportation, but barge, we know that it's slow, and they refer to it as being moderately reliable. I would say that the reliability has really been hampered or even dampened by the effect that we tend to have a lot of the floods in the spring, and in the winter, whether we have the Mississippi River frozen, etc., it tends to make a lot of problems for moving things by barge. We'd like to move everything by air, but unfortunately it's so costly that it really does prohibit us from doing too much of that at all. At the bottom of this slide, you'll see that we have relative cost of performance. Now, while these prices are probably stuck in about $2004, what I think still holds true today is the relative differential between the various modes. So let's take a look at that. If you look at the price per ton for truck, it's somewhere at around a little bit over 26 cents per ton mile. Look at our next option in terms of moving something faster, which would be air. It's roughly or close to about 2.5 times what it is for truck, and I think in some instances it could be more than that. Well, let's think if we could ship truck to intermodal. Intermodal's not represented here, but it's very competitive with truck itself, so I would expect that rate to be the same, and in fact I'm told in some lanes it could be a little bit higher. If we're talking about freight that could move by the rail, those general commodities that we talked about itself, that's somewhere about 2 cents a ton mile. So look at that differential between rail and truck. It's about a factor of magnitude of 10 itself. Look how inexpensive it is to move something by water. And then if we look at pipeline, it's certainly not the cheapest. That would go to water. Rates are generally a function of 2 criteria, and then there's a special type of rate that we need to look at. The 2 most often used factors to determine what a rate or cost is going to be for a transportation shipment is about volume and then about distance. The economies of the transportation industry show that cost of service really are related to the shipment size itself. That's why in many cases if you look at the tariff or the rate structure, we'll have things that are less than 500 pounds, and that's when we talk about truckload rates starting at about the 30,000 pounds or even 40,000 pounds or greater. Rate structures in general reflect these economies as shipments in consistently higher volumes can be transported at lower rates than those smaller shipments. We've talked about that leveraging the transportation dollar. Now remember, under volume-related rates, you might see this thing that's called AQ, or any quantity. It's a minimum charge for moving freight, and we have to have that because we do have a certain amount of fixed costs that are involved, particularly in truck transportation. I would simply say for distance that they vary directly with distance, and that is certainly a component that is built into the tariff structure itself. Now, uniform rates is a rate structure that's just built around this whole idea of simplicity. it is one where we can transport whatever we have at the same rate regardless of the distance that it travels. And I wouldn't say that's for volume. And the best example I can use for a uniform rate would be the U.S. Postal System, where we can do that first class postage and it will move a letter up to a certain weight for that particular letter across the U.S. or the states themselves. If we tried using a uniform rate structure for truck transportation, where the line haul rates are at least 50% of the total cost, it would really raise serious questions about the rate itself, simply because we know that the previous two criteria, volume and distance, have a great deal to do with the actual cost itself and is such reflected in that rate. Now that we've looked at the various rate profiles, let's look at line haul rates. Of the transportation costs, the primary component involves the line haul portion itself. So if we look at these types of rates, there are three main ones: the tariff, the contract, and then this thing that we're calling freight all kinds. Under the tariff, you'll see that there are three subgroups here: class, commodity, and exception itself. Line haul rates, generally if we look at those, and even at the tariff, we look at things like the product and the value of the product itself. We also look at the cost being related to the shipment size itself, and even lane can impact that. What is the tariff? It's just simply a transportation price list. We give a product a class rating that reflects things like its value, its damageability, in other words, how fragile it is, the storability, how easily can we stack it or not stack it in this case. And so for every single commodity that's out there, from widgets to the most complicated technological product we might have, there's going to be a class rate. That's not true for commodity and exception rates. Both of those cover very different aspects or spectrums or parts of every item or every product that's out there. Commodity generally is set aside for those products that are moving in volume and also are of a particular class. An example of that might be moving canned vegetables. It might be moving bulk load paper, etc. As I said, those are instances where the carriers have granted us that rate over certain lanes, etc. If you look at exception rates, those are for competitive purposes. They might simply be published because we know for whatever reason one of our competitors might have a manufacturing differential that we're trying to overcome, and so we will actually have that published, as I said, very specific to a commodity and a particular lane itself. And that's not going to be broadly given, that exception rate, to a lot of either shippers and or products itself. Contract rates speak for themselves. They take precedence over the class rates. I would say that today the majority of freight that moves on a regular basis, we have that under contract for any number of reasons. I think we want to secure the capacity, and we want to secure that capacity at a certain rate itself. Now, many shipments, if you look at LTL carriers, I've been told that on average you might have anywhere from 100 to 200 different shippers or consignees that are in a particular LTL. If you see the tractor trailer going down the road, and it might very well be that of those customers that freight is being sent to, that we don't want to cross their order, look and do a specific assignment of their class ratings, and we would just simply want to have all of that freight classified under this FAK standpoint. It's really useful when you have mixed shipments. Freight forwarders are frequent users of this type of rate. They allow for cost providing the transportation service rather than the value of the service itself. Now that we've covered this background, we're ready to start in class looking at this concept of freight consolidation and how the break rate plays into that. And that's where we're going to pick up with lecture.